The change in internal energy of a system is equal to the heat added to the system minus the work done by the system. Now you're probably wondering, what the hell does that mean? What the fuck does that mean? Like what, I've never even heard of that shit before. What I've basically just given you is the first law of thermodynamics. One of the more important laws. And remember, in mathematics, change is represented as a triangle. And you might have seen this equation one time in your life before, but that's basically what it means. The change in internal energy is equal to the heat added to the system minus the work done by the system. Now, understand that heat doesn't necessarily have to be added to the system. Now, let's say I have gas, because gas is typically the easiest way to understand this, right? Let's say I have gas, and this is our little system, right? And I add around 800 joules of energy, 800 joules of heat energy into this. And the gas expands, right? It expands, which means that the gas is doing work. And let's say that the gas is doing 600 joules of work. This basically means that the change of internal energy would be 800 joules minus 600 joules. And the change of internal energy in this case would be 200 joules of internal energy. That's basically what the first law of thermodynamics is. It's very simple, very straightforward, nothing too complicated. Now understand that work and heat in this case doesn't have to be positive, all the time. Now, what this basically means is that if you took the same system, and let's say that the system loses 800 joules of heat energy. It loses that. It releases 800 joules of heat energy, into the surroundings. And work is being done on the system, and typically when it comes to gases, because that's the example we're using, we're talking about gas compression, right? So if I were to take, let's say, a compressor and just crush this, piece of gas, piece of gas, I know it really doesn't sound right, but let's just say I do, and I were to crush this piece of gas, and because of this, the work being done on the system by the compressor, let's make the compressor this purple thing. The work being done on the system by the compressor would be, let's say, the same number, 600. What was that? 600 joules. Then that basically means that work in this case would be negative, and the heat would also be negative, because I am losing heat, and the work that's being done on the system, on the gas, right? The work that's being done on the gas basically means that I'm losing work, because if it was positive, it is the work done by the system, not on the system, if that makes sense. And yes, these terms, like these words, are very, very important. You're going to get screwed over a lot if you do not pay attention to how the words are used. So you take minus 600 joules, that's the same color, minus 800 joules. And then if you add these together, negative times negative in mathematics is the same thing as saying positive, so it's going to be 800 joules plus 600 joules, which is equal to negative 200 joules. Negative 200 joules, and that is the change in internal energy. Sorry, just let me rephrase that. All right, and let me get rid of this as well because we don't really need it anymore. Now, just to make sure that you guys understand, all of these quantities are measured in joules. Now, what is a joule, you may ask? A joule is a measure of energy, and it is equal to, let's use a different color here, 1 Newton times a meter. Let's use orange for the meter. Right? 1 Newton times 1 meter, because that is basically what a joule is. It's basically taking a force, and how much that force is basically being pushed by a distance, if that makes sense. Right? Now, this is the same thing as saying kgm. I'm running out of colors here. Kg, which is kilogram, times meters squared. Since a Newton is kgm, you're timesing another meter onto that Newton, so that would be kgm squared over, and last color would be, let's use blue, seconds squared. Joules is equal to Newton times meter, which is equal to kgm squared over second squared. And that all of the quantities in the first law of thermodynamics is measured in joules. And joules is basically a measure of energy. Or the unit to measure energy, excuse me. That was terrible handwriting.